All right, today we're going to take a look at something really cool. It's an open source project called PulseCare Telehealth. And it's way more than just another app. It's basically a complete blueprint for building really complex, production-ready software today.
So just imagine you're a developer. The boss comes to you and says, we need a secure, scalable telehealth platform. I mean, that's a huge lift, right? You've got to think about different user portals, microservices, multiple databases, security, scaling. I mean, where do you even start?
Well, that's exactly where a project like PulseCare comes in. It's built to be that starting point. It's a complete, working example that has already wrestled with all those tough architectural decisions, giving you a solid pattern you can learn from, you can adapt, and you can build right on top of.
Okay, so before we pop the hood and look at all the tech, let's just talk about what this thing actually does. From a user's point of view, what's the experience like for the patients and the doctors who are actually going to use this system? The workflow is actually super simple and really smart. First, a provider, a doctor or a nurse, logs into their staff portal, which is built in React, and they just mark out when they're available. Then, a patient hops on a completely separate portal, this one built in Vue, to find and book an open slot. And finally, when it's time, the provider kicks off a secure video call using Jitsi, and the patient joins. It's that clean separation that gives both users an experience that's tailored just for them. All right, now for the really fun part. Let's peel back the layers and look at the actual blueprint for this whole system. How is all of that slick user experience actually powered behind the scenes? This table really lays it all out. It's a classic, modern microservices setup. You've got those separate front ends we talked about. The back end is all Java 21 with Spring Boot, broken into small services. Everything is put into containers with Docker and then managed by Kubernetes, which means it's totally ready to scale. Every piece of tech here was picked for a reason, to do its one job extremely well. And this language breakdown kind of gives you a snapshot of the project's DNA. No surprise, Java is the big one. It's powering that whole backend. But what's really interesting to me is the amount of shell scripting, almost 20%. That's a huge signal that this project was built from day one with automation in mind, for deployment, for local setup, the whole shebang. And let's be clear, this is not just some simple Hello World demo. This entire project was engineered from the ground up to handle the messy, unpredictable challenges of a live production environment. So let's look at some of those real-world features. This is really where PulseCare proves its worth. It can scale automatically, so when traffic spikes, Kubernetes just adds more resources. It's designed to be HIPAA-friendly, which is critical. It actually masks personal information in all the system logs to protect patient privacy. And with full observability through tools like Prometheus, you can see exactly what's happening inside the system at any time. These things aren't tacked on at the end. They're baked into the core of the architecture. I absolutely love this architectural decision. See, instead of forcing one database to do everything, they use two different databases for two different jobs. For the critical stuff, patient records, appointments, they use PostgreSQL because you need rock-solid data integrity. But for things like audit logs or system notifications, which are more like a constant stream of events, they use MongoDB because it's super flexible. It's just a really smart, pragmatic approach. Look, in an app like this, security isn't just a feature, it's everything. And it is baked into every single layer here. You've got secure JSON web tokens for authentication, strict role-based access so users only see what they're supposed to, and all the passwords are, of course, hashed with bcrypt. This thing was designed to be a fortress from the very beginning. Okay, so this is where the story of how this project was built gets really, really interesting. This wasn't just a developer sitting down and coding it all line by line in the traditional way. It was actually created using a very modern AI-assisted workflow. Now, the process wasn't just, hey, AI, build me an app. Not at all. It was this really disciplined three-step dance. It started with incredibly detailed prompts, telling the AI exactly which microservice patterns to use, which security best practices to follow. The AI then generated all the initial code and logic, but in this is the absolute key. Every single line of that code was then put through a rigorous human review for security, for performance, for correctness. Think of it this way. AI provided the first draft, but a human expert was the final editor. And that human review is backed up by what is basically a fortress of automated tests. This is how you build real confidence in the code. You've got unit and integration tests making sure the backend works, component and end-to-end tests making sure the front ends are reliable, and even load testing to make sure that the auto-scaling actually works under pressure. This is what a truly professional validation strategy looks like.
So, when you step back and look at the whole picture, the smart architecture, the production-ready features, that disciplined AI-assisted development process, it becomes crystal clear. PulseCare isn't just a demo app. It's a powerful, reusable pattern. It's both a fantastic learning tool and a serious launchpad for anyone who's been tasked with building the next generation of complex software.
And that really leaves us with a fascinating question, doesn't it? If AI tools can get this good at generating the complex, well-architected blueprints, developers can stop spending so much time on the plumbing and the boilerplate and start focusing more on real innovation. It frees us up to solve bigger, more interesting problems. So, what comes next? What new frontiers are we going to unlock when the starting line is already this far ahead?